In this video, we are going to learn service mesh pattern and how does the service mesh pattern works for microservice deployments. A service mesh is a pattern for managing the communication between microservices in a distributed system. It is designed to provide a uniform way to route traffic between microservices and handle load balancing and monitoring the health of the system. A service mesh is typically consists of a set of proxy servers, also known as sidecar patterns, that are deployed alongside the microservices. These proxy servers handle the communication between the microservices and are responsible for tasks, for example, routing requests, load balancing, and monitoring the health of the system. One of the main benefits of using a service mesh is that it allows you to abstract away the complexities of managing communication between microservices. Instead of having to manage these details at the application level, you can use the service mesh to handle them automatically. This can make it easier to build and maintain complex microservice-based applications. There are several popular service mesh implementations, including Istio and Linkerd. These implementations provide a set of tools and libraries that can be used to set up and manage a service mesh in a Kubernetes cluster. The service mesh pattern is a good choice in situations where you want to manage the communication between microservices in a distributed system. Let's explain some of the specific scenarios where the service mesh pattern might be a good fit. The first reason could be when you want to abstract away the complexities of managing communication between microservices. A service mesh can help you manage the communication between microservices in a way that is transparent to the microservices themselves. This can make it easier to build and maintain complex systems. And the second reason could be when you want to centralize the management of communication between microservices. That means by using a service mesh, you can centralize the management of communication between microservices in a single place. And another reason could be when you want to add features such as load balancing, traffic management, and monitoring your microservices. A service mesh can provide a number of features that can be useful in a microservice deployment, for example, load balancing, traffic management, and monitoring. So we can say that by using a service mesh, you can add these features to our microservices without having to modify the microservices themselves. So the service mesh pattern is a useful tool for managing the communication between microservices in a distributed applications in Kubernetes clusters. It can help to build and maintain complex microservice-based applications by abstracting away the complexities of managing communications between the microservices.